Okay, it's 9:16, so we are ready to go again. Recording is running, and as promised, we are now going to design an API with a standard which is called OpenAPI Specification, or the less formal name of that is called Swagger. Swagger is a standard for describing APIs. What's the core idea of Swagger and OpenAPI Specification? Imagine that I gave you just a URL for a server which offers a web API. Let's say api.rainasgreatserver.com, and I tell you, use this API. Your next question, your response would immediately be, what API? What are the URLs? What verbs, what methods does it support? How does the data structures look like? Give me some documentation, Rainer. That would be probably your response. And this is exactly where Swagger lives. Swagger is a formal specification standard for describing what a server is able to do. Swagger is you know what swag is? You can do your own picture search in Google for the word swag. Yeah? It's like being proud and standing here and saying, hey, see what I can do. This is what I offer you. And this is what Swagger is all about. Well, Swagger is a very informal name, so when banks and insurance companies started using web APIs, they needed a more senior, a less funny name as Swagger, and therefore they came up with the formal name OpenAPI Specification. But essentially, if you hear OAS, OpenAPI Specification, and Swagger, it's all the same. Yeah? So you can use the word Swagger or you can use OAS, just as you like. If you want to read the entire specification, you can go to Swagger.io, go to Resources, OpenAPI Specification, and then please go to OpenAPI Specification 3.0. We are going to use the latest version of OAS in this course, so 3.0. And then you have a long document what you can do with OAS. I do not expect you to read the entire specification and to know it by heart. Of course not. I will show you in this lesson the most important concepts of an OpenAPI specification. But believe me, if you work in practice, if you are going to be a professional developer for microservices, distributed systems, and so on, you will probably have to, at one point in time, read this documentation, the specification, to understand all the features of OAS, because it is super relevant and very, very important. I don't know a single company out there building web APIs who does not use the OpenAPI specification in one or another way. Now, how can we write such OpenAPI specifications? We go to Tools, and here you find a nice tool which is called the Swagger Editor. This is a nice tool which you can use for simple use cases if you just want to type in some Swagger code. You can go to Download. You can try it in the cloud, or you can just click on Live Demo. You see that one? And this is the one that we are going to use in this course mainly. So click on Live Demo, and that will bring you to editor.swagger.io. And in this editor.swagger.io, we are going to design our upcoming API. Okay? Here on the left-hand side, you can enter the Swagger file, and on the right-hand side, you see the human readable documentation that is auto-generated from your Swagger code. Okay? This is your page. This is the generated documentation. In practice, every API project starts with writing, or should start with writing, such a specification document. Somebody sits down and thinks hard about what should my API do. Somebody writes this document by hand. And this is then your specification as a developer, and you have to build the code in C#, in JavaScript, in TypeScript, in Go, in Java, whatever. You have to write the code that implements the specification written here in Swagger. Okay, this is the ideal workflow for building an HTTP-based web API. To be honest, for simple API projects, if you are very, very experienced, sometimes you skip the step of writing such a specification because you write the specification in your mind. You just know what you're doing. But if you are new to APIs, it's a very good thing to start really not writing code, but first specifying what the API is all about in such a file. And this is what we are going to do. If you already have some code here on the left-hand side, I ask you to delete everything to start from a blank page. I will zoom in a little bit so that you can read my text properly. It would be good if you follow along now. So I would encourage you to open editor.swagger.io and try to follow along by typing in the code that I type in. If you prefer just focusing on what I show you, it's not absolutely necessary that you follow along. But I would encourage you to do that. I think it sticks better in your mind if you type in the code yourself. But at the end of the day, it's up to you whether you want to just watch or whether you want to type. The first line in a Swagger file is always the same. It's OpenAPI, and then you specify the version of the OpenAPI specification that we are going to use. And the latest version is 3.03. That's the latest version of the OpenAPI specification. Okay? Good. Then we can start implementing or designing the API. There are two options here. Either you know by heart what the Swagger specification is all about, and you know that, for instance, there is an info block, and then there is a servers block, and then there is a paths block. It might happen that you know that by heart, but to be honest, if you are a beginner, you probably don't know the Swagger specification from the top of your mind. Therefore, you have this nice little cool tool here, insert, with which you can generate some of the most important aspects of your Swagger file. So let's go to add info. That will add the first basic information block about my API. I thought about what we should generate, and maybe at some point in time Corona will be over and we are going to do events again, maybe parties or maybe some trainings or whatever. So therefore we are going to design a very simple event management API. So the title will be Event Management. This is a web API for maintaining a list of events. You can specify a version. This will be the first version of my API. And if we want, we can add a terms of service document, which is just an end user license agreement if you want. We can also skip that one. We can add a license for the API, which might be an open source license, for instance. And we could add some contact information if somebody should be able to contact us in case of questions. It's not that important. We just accept that one, click on OK, and here you see this is the first block. It's a basic block about information. What is this API all about? And if you take a look here on the left-hand side, this is the header block, which just tells the user a little bit general information about our API. The next thing that we could add is the servers block. The servers block can also be generated here, add servers. And here we can specify an URL of a server that implements this API. This is optional. You don't absolutely need to add the servers block because this only is there for interactively trying the API directly in the documentation. So if you haven't implemented the API yet, just leave out the servers block. The servers block can be added later on once you are done with implementing your API. Did I hear somebody turning on the mic? Do you have any questions? Okay, not good. The next block, which is really important, is the paths block. We have to type in paths by hand, and here we can specify the, as the name suggests, paths, so the thing that comes after the server name, api.myserver.com/API/something, okay? This is what we can specify. And in our case, we are going to implement an event management. So I think one of the most important paths might be /events. Here we are going to design all our operations which relate to events. Add an event, delete an event, get all events, get a specific event, all this stuff. And in real world, you really sit down and think hard about how you design the paths. In our situation, it's very simple because we just have events. But in a real world API, you might have dozens, hundreds of different entities that you want to maintain. Think of SAP, think of CRM systems, think of other large order management systems. They have dozens and hundreds of these paths. And sometimes it's really not simple to come up with meaningful names and a meaningful structure of the paths. In real world, designing such paths, designing the structure of the API is really something that is not trivial. In our case, we are just learning here, so it's very simple and very obvious. We want to add events. Now we can add the first very simple operation, get all events. Of course, we are going to use HTTP GET because we want to read events. So we can now either manually type in the specification of the API, or if you click here, we can add an operation interactively. So here you can go to add operation, select the event, and then we have a nice little GUI here with which we can type in all the things which are relevant for our operation that we want to design. In our case, we are going to say get because we want to read information. Let's add a short summary. Returns all events. Yes. You go to, you have to add these two things here, and then you go to insert operation. Okay? You select events, you select get, and then we specify a short summary. Returns all events. We can add a description if we want. For instance, we can say, I don't know, return a list of all events in the database. Okay? Now, check that one out. Isn't that great? We can use Markdown for the documentation. So what we can, for instance, do, we can say star star to write something in bold. You can add links and things like that. So you can really use Markdown. The Markdown you might be used to from Discord or GitHub and so on. The last thing which is important is the operation ID. It's a technical identifier for the operation. Let's call it get all events. We can add some tags here at the bottom here if we want. Tags are used to structure all your operations. And this operation is related to events. So I'm adding a tag which is called events. If we, for instance, add additional operations for managing attendees, then we can add the tag attendees for all the APIs related to attendees, and then it will structure my visual documentation in a very nice way by taking the tags as a kind of headers. Okay, add operation. And here you see, I have to decrease the font size a little bit, otherwise I can't meaningfully show you what is generated here. On the left-hand side, you now see the specification of our event. And on the right-hand side, you immediately see a human readable documentation that already says returns all events. You see the bold text, so Markdown was correctly interpreted. You see, we don't have any response codes. We don't have any parameters yet. Of course, we have to add now more details to our event. But generally, we have already specified our first API operation. Nice. Good. Now we can add a bunch of things here, and those things are pretty important when you do real-world API design. Some of the things that I'm going to show you now are not available through the GUI, so here, but some of them are. So for instance, let's add external documentation, just as an example. If you do that, you can add here a URL, http docs.myserver.com API, and a description, read more in my great API docs. It's just an example, okay? So if you add external documentation here, now we have the external documentation, and if we want to have this external docs not on a global level, now we have here a global documentation, but if we want to have the external docs specific for this get all events, all we have to do is to move it here, indent it a little bit, and here you see, now we have the documentation here related to my documentation of this specific operation. So it depends, it's a YAML file, so therefore the indentation depends on where you want to add the external documentation to. Good? Nice. The next thing that I would like to show you is how we specify a parameter. Okay, we can do that, but we will not do that through the GUI. To be honest, I don't know whether you can do it here. I can't read it. I typically do the parameter definition by hand. So please follow me. I will just type in the code directly here on the left-hand side. Because what we are now going to do is we are going to define a common schema. What is a schema? A schema is a data definition, a data structure. And we can define the data structure and then use it in our API definition. Because we are now going to define what is an API event all about. It can have an ID, it can have a description, it might have, I don't know, a date, it might have a URL with some specific information about that event. And this kind of data structure, this kind of schema is the next thing which we are going to write. And this is done in the components section. The components are things where we specify on a central location data structures which are then referenced from our operations. Okay, so we are going to define schemas. Components, schemas. Now let's define an event schema. The event is a type object. This object has some properties. A property could be, for instance, date. It's the date of the event. A property has a type. Unfortunately, JSON, we are going to use JSON in the Web API, doesn't have a date data type. So a date is represented by a string, but we can still document that the string has to adhere to the format date time. And we can also add a description, date of the event. Now you might ask yourself, how does Mr. Stropek know all these things? Why does he know what's available here? So, first, I am cheating a little bit. I have, of course, in the preparation for this lesson, I have thought about what I want to do with you. So I have my course notes on the second monitor, because to be honest, I don't know all these things by heart. But what do I do in real world if I don't know them by heart? Well, I go to swagger.io, I open, maybe on the second monitor, the OpenAPI specification, and if I go here to specification, then we can take a look here in schema, and guess what? See, components. Here, schemas, see? Schema object. And yeah, if we take a look at it, see? All the things that I'm currently using. And if I scroll down a little bit, you will see, yeah, now it's okay. You will see examples here. See that? So all I did in preparation for this lesson is I took a look at the specification and I remembered how to define an object by taking a look here at the documentation. But I spare you this, this step because I have already prepared it. But I wanted to show you where you can get the documentation from when you want to know what's possible inside of these files, okay? Once you get used to writing these things, you know some of the things by heart. I would probably have been able to specify all that things just from the top of my mind because I've written so many Swagger files in my career, but all the details, whether this is called date time or date dash time, I don't know that by heart. I often have to look it up in the documentation, but this is what documentation is all about. Now, let's add the next property, location. It's again type string. This time, it's just a string. What we can do is we can say this is a min length, for instance. We can specify that, 10. It has a max length, let's say 250. And then we can say a description. It is the location of the event. Of course, I think you can imagine that we are able to add more and more and more properties. The only property that I really would like to add here to this object is the ID property. I will put it here at the beginning. It's of type string. It could also be an integer. Oh, let's use an integer, okay? Let's use an integer. It's better. Let's use an integer. The format could be, this is an integer 32. We can specify a minimum if we want, for instance, 1. And the description would be primary key for events. Now we have a nice data structure, and if we take a look in the human readable documentation, you can see all the details. So somebody who uses our API will immediately understand what an event is all about and which information has to be passed in if, for instance, the person would like to create an event. So here we have schemas. If you want to add additional things, then we could add here now attendees, and then we add properties and things like that. We will not do that yet, but I think you get the idea how this is done. Good. This is an event. One thing is also important. We can specify here not just the type, but we can also specify required fields. We can say, for instance, here that the ID is required. It must not be empty. Maybe we can also say the date is also required because that makes sense. The location is not mandatory, it's optional. So required is another important thing that we can specify. And if we take a look here, now these two things are marked with an asterisk. So yeah, they are mandatory. Good. With that, we can now go up again to our events get and specify that this event requires a parameter to be passed into this operation, get. We can say we need a parameter. We don't have a get return something. Yeah, forget what I said. We don't need a parameter. We want to return something. Okay, so what we really want to add here, we want to add responses. Now the first inside of these responses is the response status code. What would be a meaningful response status code for a get event operation? 400, 300, 500, 200, 201? Okay, 200, exactly. So what we can specify here, we can say we have a response 200. And then we can say a description, success, for instance. And the content will be application slash, oh, I just recognized that responses was auto-generated up here. I'm very sorry, I didn't see that. So just delete the auto-generated responses here. I'm sorry. Application slash JSON is the format that we want to respond. And which kind of JSON? We specify a schema. The type is an array because we return multiple events. And the array items have a reference to components, schemas, event. So we have a reference, we have a reference here for the get events. We return an array of, this data type. Another possibility would be that something bad happens. 500, description, internal server error. And we don't specify anything else because if something with 500 exists, we don't know yet what we want to respond. And if we take a look here on the right-hand side, you will now see here that the response code 200 success will return application slash JSON, and it will return an array of event objects which contain a numeric ID, a date, and the location in form of a string. So you see, now if somebody asks you, what can this great API do for me? The answer is that here on the right hand side. And this is generated from this code here on the left hand side. Now, do you think it's a lot of fun writing all these things? Well, not really, but it's necessary and it pays off. And now you might have the impression that knowing all these things by heart is somewhat difficult, but hey, it's the same with C#, isn't it? You have to know that there is a for loop. You have to know that there is an if statement. You have to know that an asynchronous method starts with async. You have to know so many things. But for the programming languages that you are used to, it just comes naturally to you. So this is just a new language, and therefore at the beginning it's somewhat overwhelming and somewhat confusing. But believe me, if you work a lot in the area of specifying APIs, this is your daily business, and it will be so easy to read and so easy to write. Do you absolutely have to use the editor here? No, it's just a text file. Of course you can use Visual Studio Code if you want. There are plugins for Swagger in Visual Studio Code. So you can have exactly the same environment with a nice Visual Studio Code editor here and even show the generated documentation here on the right hand side. Everything can be done within Visual Studio Code if you want. And there are many other tools with which you can define OpenAPI specifications. But let me ask you now, do you understand now the general principle of defining an API with Swagger? Do you have questions at that point in time? Clear so far? Nice, very good. Good, so let's stop here. Let's stop here by adding and writing the Swagger documents manually. I would like to give you the classroom link for today's exercise and homework, and I ask you to generate, to clone the exercise, because there is a Swagger file in the exercise and we can take a look at it together and try to read it. It doesn't make sense that we now spend another hour or so typing in this code. It's way more important that you understand the general concept, because you have to use it and you have to practice that in your own projects. There it makes very much sense. So let me quickly get the classroom link for you. Give me a sec. I have to look it up. This is the classroom link. I will also paste it now in the Teams meeting. You can either type it in or just click on the link which I just posted in Teams. I will also post it in Discord, okay? I will also post it in Discord. Now you have it in Teams, you have it in Discord, and you have it on the screen. So choose whatever works best for you. And I will open the specification here while you are cloning your GitHub Classroom. Here we see the Swagger file. What I'm going to do now is I'm going to copy the entire Swagger file here, copy it, and paste it in my Swagger editor, so that I see whether I messed something up, but it looks pretty good because I don't see any warnings or errors here. And you see that this API is a little bit more complete. It's about maintaining an address book, a list of contacts. This is what you have to implement for your exercise today or for your homework. But let's take a look at the structure of the Swagger file first. So you can either do exactly what I showed you now, take a look at the swagger.waml file inside of the GitHub repository that you just created by copying or by subscribing to my classroom link, or you can just take a look at my screen here. You see, in that case, we have a single API endpoint here, which is called contact, but now we have multiple operations. Here you see the get, the post operation, and question. Oh, really? Did it stop? Okay. Okay, I will, yeah, or I will quickly stop screen sharing and reshare my screen. Maybe it's a problem on my side, but I'm still sharing, but maybe it's a hiccup. So I stop screen sharing now, and I start sharing again. Okay, very good, very good. So you see, here we have the get operation. I can fold it here. Here we have the post operation. I can fold it here. And then we have a different path. If you take a look here with a variable in it, and we have a delete operation. We also have an operation with which we can find a contact by name. This is that one with get. And down here, we have the schema of the contact. Okay? Now let's take a look at the different operations. The first one, the get one, is pretty simple. It's just an operation which returns status code 200 JSON array of the person. This is what we did together. Very simple. Now the post operation is a little bit more complicated, because here you see we specify a request body where we say we expect in the request body a JSON representation of the person to add. This request body is mandatory, it's required, and guess what? We now do not return a 200 status code, but we generate a 201 status code, which is called created. We return the inserted person, and we also set a response header, which is called location, with the URL where the event can be queried after it has been created. So this is how you specify a response header in a Swagger specification. The next one is a different path here. You see it? Here we have a path which also contains contacts, but it has an additional ID here. So this is where we specify the ID in the path. And here you see the parameter, and this parameter here relates to this path, this part of the path. Here you see this is a path parameter, and we can specify that the person ID has to be an integer value. If everything is fine, we return 204, no data. After it has been deleted, no data is fine. If the ID is not an integer value, we specify 400, bad request. If the ID is a correct number, but there is no person with this ID, we return 404, not found. These are the status codes that we talked about in the first hour. Last but not least, I modeled here a different endpoint which is called find by name. We could have also combined that with the get up here, but I wanted to do it in this way because then I can show you some additional things in ASP.NET Core. And here we have a different kind of parameter. We have a query parameter. So in this case, we are going to use API contacts find by name question mark. Name filter equals to foo. Yeah, so this is the name filter, and this name filter is going here. Oops, I think you get the idea. If everything is okay with 200, we return an array of people whose name contains this name filter. And if we respond with 400 if there is no name given. So if the name is empty, then we return a 400 bad request. Do you get the idea? Do you understand what the value is of this kind of specification? In this case, in this homework, I want you to write in ASP.NET a web API. Now, I could have written down in plain English or German a specification, but that is not as formal and exact as I want it to be. If I give you that specification, then you know as a developer exactly what you have to do. You have all the information to start coding, and that's the idea of writing such specifications ahead of writing code. It forces you to sit down and think hard about how you structure your API, about the parameters, about the data structures. And only if you have at least a rough idea how your API should look like, then and only then you start coding. Otherwise, you start coding, and in the middle of the coding work, you recognize that maybe you have a logical mistake in your concept and you have to start over again and again and again and again. For such tasks, it's much easier to force you to first think at least a little bit about the concepts that you want to embed in your API. And then when you have a clear picture in your mind, then you start coding. Don't get me wrong. I'm not saying that you have to specify, that you have to build a perfect specification before you are allowed to write a single line of code. That would not be agile development. We want to stay agile, but even if we are agile, we have to spend a little bit of planning up front to get a kind of mental picture, a kind of mental model about what we want to do. It's just like you want to go from your hometown to Vienna. Of course, you can be agile. You can not think about how to get to Vienna and just leave the house and start walking. And maybe at some point in time, you meet somebody and ask somebody, hey, am I on the right track to Vienna? And maybe you just spent hours walking in the wrong direction. So a little bit of planning up front is absolutely necessary. You don't have to have an exact plan about everything, but it is necessary to do a little bit of planning, even when you do agile development. Okay, this was the second lesson of our lesson today. In the first lesson, we repeated some concepts about HTTP, about status codes, about queries, about cookies, and things like that. You heard me messing up with some tails. I switched the Rotkäppchen with Hansel and Gretel. That was the first hour. And now in the second hour, you learned about Swagger and OpenAPI Specification. You learned the concepts of these specifications, and we took a look at a, granted, simple example, but still a practical example which will be relevant for your exercise today. So with this, we spent another hour, and it's time to do another break, okay? We spent now, I don't know, 40, 45 minutes. I think it's a good idea to have a short break, because now we will again switch gears and dive into our third hour. And the third hour will be writing code in ASP.NET Core. We are going to start with implementing a very simple API, and I'm going to show you things which you haven't learned until now about how to use ASP.NET Core. And when we have done that, you can spend the rest of today's lesson working on this example, which you just cloned from the GitHub Classroom. So now it's 9:57, let's say 10. Let's make a 10-minute break. So at 10 minutes after 10, we will meet again and dive into ASP.NET Core. See you in 10 minutes.